Hello everyone, welcome to Know Exasol series episode 5. In the previous episodes, we have looked at the architectural building blocks behind Exasol's performance. We covered columnar storage, massively parallel processing MPP, shared nothing architecture, and how Exasol uses main memory. Together, this explains where data is stored and how work is distributed across the cluster. But there is another important piece. When you submit a SQL query, how does Exasol decide what each node should do, in what order, and how to execute that query efficiently? That's the role of the execution engine, and that's what we are going to explore in this episode. Let's begin. So, why every database needs an execution engine? SQL is a declarative language. We tell the database what we want, not how to produce it. So, looking at the example query, we simply ask for a total revenue by region. But internally, the database still has many decisions to make. Which table should be scanned? Should filters be applied before joins? How should joins be executed? Should data be redistributed across the nodes? Should an index be generated? All of those decisions happen before the first row is processed. That's the responsibility of the execution engine. So, one of the most important components of the execution engine is the cost based optimizer. According to the Exasol's documentation, when a query arrives, algorithm optimize the query, determine the best plan of action, and generate indexes when required. The optimizer evaluates different execution plans using statistics about the data. It estimates the cost of each possible plan and selects the one which is the lowest estimated cost. It can also apply optimization such as creating indexes automatically and applying filters early in the execution plan where appropriate. All of this happens automatically before the query starts executing. So, how the query flows through Exasol? Let's look at the complete execution flow. A client connects to any node in the cluster. The node accepts the query and distributes it to the rest of the cluster over the private network. The optimizer creates the execution plan. The work is divided into parallel tasks. Every node executes the same plan against its own local data. Finally, the partial results are combined and returned through the original connection. This is the single program, multiple data model that we introduced in the MPP episode. Distributed joins. So, distributed database introduce another challenge. The rows required for a join may already be stored in the different nodes. Before the join can execute efficiently, the execution engine may need to bring the relevant data together. Depending on the execution plan, Exasol may redistribute data across nodes so matching rows are co-located. In other situations, it may replicate a smaller table so every node can perform the join locally. The objective is always the same: move as little data as possible while allowing every node to continue processing in parallel. Automatic indexes. Another important capability is automatic index management. Traditional databases often require DBAs to predict which indexes should exist. Exasol takes a different approach. When the optimizer determines that an index will improve query execution, it can create that index automatically. Those indexes can be reused by subsequent queries and are removed automatically when no longer needed. The goal is to reduce manual administration while allowing the optimizer to adapt to changing workload. So, what the execution engine delivers? When all these capabilities work together, the benefits become clear. The optimizer chooses efficient execution plans. Automatic indexes reduce manual tuning. Distributed execution allows every node to contribute to query processing. Local processing minimizes unnecessary data movement. Together, these capabilities enable efficient execution of analytical workloads across the cluster. So at this point in the series, we have covered the major architectural building blocks behind Exasol's performance. Columnar storage reduces unnecessary data access. Main memory minimizes disk I/O during analytical execution. MPP distributes work across the cluster. Shared netting architecture removes centralized bottlenecks. And the execution engine brings all of these capabilities together by optimizing, planning, and coordinating query execution. In the next episode, we will look at another important part of Exasol's architecture, XR Cluster OS, the component responsible for managing and coordinating the cluster itself. See you in the next episode.